All right, here we go. What are the domain and range of the distance function? So copy the distance function here. We got the distance of y is equal to the square root of 10y squared plus 30y plus 25. Now, we already found what the minimum distance was. Remember, we went through and we um, found that the axis of symmetry of this quadratic, and try not to get too distracted by the fact that there's a y in here, because really this is just a quadratic. If it was 10g squared plus 30g plus 25, you would still solve it using a quadratic model. And so kind of actually went ahead and graphed it here for you. Notice that that function never is negative. The output are never negative. And so because of that, um, we can't get a negative inside of our radical here. That there's no value for y I can plug in that will give me a negative output. And so, yeah, our domain here, our domain is all real numbers. We can plug in anything we want for y, and will never be, actually let me write that part out a little more explicitly, 10y squared plus 30y plus 25. There's no way we can make that less than 0. No way we can make that negative. That would be our exclusion, but that can't happen again because all the output here are positive. The minimum is a positive number. All right, so that's the domain, all real numbers. Now the range, what is our output? The smallest output we can get, we went through and we found our minimum distance, and remember it was the square root of 2.5. Okay, so that in that case, our distance, that's our output here, our distance has to be greater than or equal to the square root of 2.5. And so domain, we can plug in any y values we want because it's a function d of y. And so our domain is all real numbers, and our range, meaning our output here, the distance is going to be greater than or equal to the square root of 2.5. All right, hope that helped.